solving these two examples, we want to remember one thing about imaginary numbers, and that is that, here we go, the imaginary number I is equal to the square root of a negative 1. Now we're used to saying we can't take the square roots of negative numbers. Your calculators won't do it. And so this is why, mathematicians created this whole other set of imaginary numbers so that we could work with square roots of negative numbers. So if we look at number 1, we would see that we have x squared equals to 13. And solving for x, we'd have to undo the squared. And so let's take the square root of both sides. So the square root of x squared is just x. Is equal to, we want to remember, because we saw the 2, that means we're going to have two answers, so it is plus or minus, and then we have the square root of a negative 13. Now, like I said, this is something that we're used to saying can't happen in math, but now we're going to use this idea over here to help us out. If we break this down for a second, let me just show you what's going to happen. It's equal to plus or minus the square root. Now our product property of square roots tells us that we can say negative 13 is equal to a negative 1 times 13. And we can break that apart. I'm just keeping the plus or minus out front. And we can say that's a square root of a negative 1 times the square root of 13. And now if you notice, we have the square root of negative 1, and over here we said the square root of negative 1 is equal to I. So our final answer, we're going to have plus or minus, this pen is crazy. Alright, so plus or minus I times the square root of 13. Because we have the square root of negative 1, it's equal to I, and so instead of writing the square root of negative 1, we can put I. And now we're dealing with the square root of 13, which is a positive number. So let's try number 2 and see how that one goes. We have 3x squared minus 7 equals negative 31. We have to find the squared term, get that all by itself. So we have the 3 and the minus 7 to get to the other side. We're going to want to add 7 first. So we have 3x squared equals negative 31 plus 7 is a negative 24. And then divide both sides by 3. So we have x squared equals negative 24 divided by 3 is a negative 8. And now I'm just going to bring this up here to keep writing. At this point we would say, well, let's take the square root of both sides. So I'm just going to rewrite x squared equals negative 8. Take the square root of both sides, and we have x equals, I'm using this different technology thing and I don't like it right now. You can tell how sloppy this all looks. I apologize for that. Anyway, x equals, now because we took the square root and we see this 2, that tells us two answers, so plus or minus the square root of negative 8. And then the square root of negative 8, we're going to break that apart. We can do the shortcut where we say plus or minus I times the square root of 8, and we would have gone through all these steps over here with this negative 13, broken apart with negative 1 times 8, and then the square root of negative 1 is I. So we have the square root, I plus or minus I times the square root of negative 8, and then our last step is, we have the square root of 8. Can we break that down at all? Do we have any of our perfect square numbers that will fit into this? This will break apart into the square root of 4 times the square root of 2. And the square root of 4 we know is a 2, root 2. So we still have this plus or minus I out in front. And our final answer is plus or minus 2 times I times the square root of 2. So there you go. That's how we can get around when we're solving an equation and we get to that square root of a negative number. We throw the imaginary number in there so that we can actually work with it.